So welcome back to my channel. Now today straightway we'll get into the topic, right? The topic is relative aromaticity and reactivity of Pyrrole, Furan and Thiophene, right? So first let's do one thing, let us proceed with the structure, how we can sketch the structure of these three heterocycles, right? So Pyrrole is the one, say all the members, they are found to be 5-membered. All this particular ring system, they are found to be 5-membered ring system. Now 5-membered means something like this, and they differ from each other with respect to the with respect to the type of heteroatom, right? So Pyrrole is the one in which you can find the heteroatom as nitrogen, fine. Furan is the one in which you can find the heteroatom as oxygen, and Thiophene is the one, the name itself suggests that I have in me sulfur, right? So Thia corresponds to sulfur, right? So now let's talk about their aromaticity. Okay, we all know that these three ring systems, they are found to be aromatic, right? And by virtue of what they are found to be aromatic, since all are found to be electronegatives and their electron, the lone pair or non-bonded electrons, they are basically involved in complying the Huckel's rule. That means 4n plus 2, and that should be a non-negative integer, fine. So as we are getting non-negative integer, and this is through the contribution of the lone pairs, right? Nitrogen is also having a lone pair, oxygen, it is having a pair of lone pairs, and same thing for sulfur as well, fine. So now the thing is that, and let me tell you one thing, we all know that nitrogen, oxygen and sulfur, all of them are found to be electronegative, right? And if we just try to find or try to develop an interrelationship between aromaticity as well as electronegativity, fine, what we observe that aromaticity is inversely proportional to electronegativity, fine. Aromaticity is inversely proportional to electronegativity, fine. So this is found to be the relationship between aromaticity as well as electronegativity. That means if a particular heteroatom is found to be more electronegative and that is found to be a part of a heterocycle, what will happen? It basically keep reducing the aromatic strength, fine. So aromaticity keep reduces once the electronegativity is found to be increasing, then vice versa, fine. Chalo. So now on the basis of this particular fundamentals, right, what we are going to see that which one is found to be superior, which one is found to be moderate, which one is found to be weak with respect to aromatic character and all, fine. So now here we'll see that if we just compare them with respect to their electronegative character, right, we have to shift our attention from here to the periodic table. What we observe there, that we have a nitrogen, we have an oxygen, now beneath this we have sulfur, we have phosphorus, right? So this is found to be the periodic table arrangement of what? Nitrogen, oxygen, phosphorus and sulfur. And we all know that electronegativity increases once we move from left to right, fine. And electronegativity also increases once we move from down to top, fine. This is found to be the strength of electronegativity, which keep escalating once we move from down to top as well as from left to right, fine. So if we just focus here, or if we just stick to this particular fundamental, so what we observe that it is the oxygen that is found to be highly electronegative, right? Then comes nitrogen and then comes the sulfur, fine. So if I just arrange them with respect to their electronegative character, it is the oxygen that should be placed on first, right? Then nitrogen and then sulfur. So this is found to be the order of electronegativity, what we can say, the strength of electronegativity rather, fine. So thus we can arrange these three atoms. Now let us just see here, fine. As I just placed oxygen right here. So oxygen is found to be the one which is found to be more electronegative. So that means the aromatic character seems to be least here, fine. Then comes nitrogen, that means the Pyrrole is found to be the second one, so aromatic character seems to be moderate here. And sulfur is found to be the less electronegative, so the one which is found to be less electronegative is found to be more aromatic, it seems, right? So if we just see, that means the sulfur is the one, since it is found to be least electronegative than the rest, than the other two, right? So that is why it is the sulfur that must exhibit, sulfur containing heterocycle that must exhibit what? Greater or greatest aromatic character, what we can say, fine. So likewise, if we just arrange them, so what will happen here? So now what will be the order of priority, right? So with respect to the aromaticity, fine. So first we are supposed to put what? Thiophene, right? Thiophene should be, kept at first, fine, because sulfur is found to be least electronegative, and we know the relationship between aromaticity as well as electronegativity, fine. Chalo. So here, as it is found to be least electronegative, that means the aromatic character seems to be higher. Now, why aromatic character seems to be higher once a particular compound is found to be least electronegative? Because least electronegatives are those which are having a tendency to furnish their electrons to the neighbors, fine. And here, in order to fulfill or comply the Huckel's rule, the lone pair is having a huge, lone pair seems to be the decider, what we can say. Without the contribution from the lone pair, the aromatic character cannot be fulfilled, right? So here, the ease at which the lone pair is given to the aromatic or the pi cloud, it indicates what the strength of aromaticity, what we can say. And that is found to be highest in case of sulfur, right? Why? Because sulfur is found to be least electronegative. So that means here the electrons are not found to be tightly held, which is observed in a highest way in case of oxygen, fine, and then nitrogen, finally sulfur, fine. So thus we can say it is the thiophene that is found to be more aromatic than pyrrole, and then at last we have furan. So this is found to be, if I just compare the aromaticity of these three ring systems, right? The first thiophene should be kept, followed by pyrrole, and finally furan, right? So this is found to be the order of aromaticity, right? Fine. So aromatic character is found to be more here, then moderate here, and least here, fine. So this is all about your aromaticity, fine. Now let's move on to the next topic, that is your reactivity, fine. Whether the reactivity is also having the same order, can we simply consider this order which we observed here for reactivity as well? Let's see, fine. Now reactivity does not depend on electronegativity actually. Reactivity, if we just say reactivity, fine, the rule of thumb says that reactivity is basically relies on mesomeric effect, especially for the aromatic compounds or heteroaromatic compound, fine, mesomeric effect, right? And here mesomeric effect. Now here we need to bring another one, that is your inductive effect, right? Inductive effect as well, right? So mesomeric effect is also the one in which what we observe, that positive mesomeric effect, what does it mean? That means the lone pair is given to the aromatic cloud, right? Sorry, the pi cloud, not aromatic cloud, rather aromatic pi cloud, what we can say, right? Aromatic pi cloud means it is the pi cloud with which we can say, but we can call a particular compound to be an aromatic if the other criteria will be fulfilled, right? Chalo. So now the thing is that, so here reactivity, if we just want to discuss the reactivity, the relative reactivity, say here we have to give the importance to the mesomeric effect, fine. So plus M effect is found to be the one in which what we observe, that the contribution is the lone pair is given to the pi cloud, what we can say, the endocyclically placed pi cloud, I mean to say this one, fine. And minus M means it is trying to withdraw the electrons, fine, and thus it is not contributing in a positive way in fulfilling the aromatic character, fine. Chalo. So now what we observe here, so if we just say consider the three heteroatoms, because on the basis of these heteroatoms only we can categorize the heterocycles. Sulfur containing heterocycle, that means thiophene, oxygen, furan, and pyrrole is nitrogen, fine. So see here among these three atoms, right, which one is found to be the greater mesomeric effect? So what it is observed, that it is the nitrogen that is having a greater mesomeric effect, fine, mesomeric effect than the rest, fine, than the rest. And moreover, it is also observed that as it is having a greater mesomeric effect, which is found to be aware, that means as it is having a greater mesomeric effect, what is observed, that inductive effect is found to be faded, what we can say. So that means here in case of nitrogen containing heterocycle, the nitrogen is the one in which you can find greater mesomeric effect than inductive effect, fine. So here it is the mesomeric effect that is dominating the process, not the inductive effect, fine. So that is why it is having, or rather it can release or the furnish its lone pair to the pi cloud, so that with the proper involvement of the pi of the lone pairs into the pi cloud, what will happen? It can fulfill the aromatic character. It can fulfill the Huckel's rule, fine. Chalo. So what we observe, that it is the nitrogen that is, by virtue of its greater mesomeric effect than inductive effect, right, the reactivity seems to be higher. or highest, what we can say. The reactivity of pyrrole seems to be highest. Why? Because the nitrogen is having a greater mesomeric effect. Fine. Now coming to the rest 2, that means the oxygen containing heterocycle, that means the furan, right? So what it is observed that, see, furan, we all know that oxygen is found to be, here we have put here nitrogen, oxygen, sulfur and phosphorus, right? Oxygen is found to be more electronegative, right? Okay. So more electronegative means less electron density on the carbon. Quite obvious, right? So if I just say, see here, so this is found to be the structure of furan, right? Oxygen is found to be more electronegative than the rest. That means the phosphorus, oxygen as well as nitrogen as well as sulfur, right? So since oxygen is found to be more electronegative, what will happen? It will always, the electrons are always tightly held with the atom, fine. So that means the electron cannot be given to the neighbor, neither to the neighbor nor to the pi cloud, right? Not, I'm not telling it is not, means it cannot be given. I am not telling ki, okay, fine, it is, complete denial is not expected, fine. It is giving, but in a lesser rate, what we can say, fine. That means it cannot readily, release its lone pair or give its lone pair to the neighboring carbon or the pi cloud. So that is the main, limitations of this oxygen, fine. Since it is found to be highly electronegative, so that is why, there is a less electron density which is observed here as well as in the pi cloud, right? So that is why what we can say that oxygen. So here what statement can be drawn here? The statement is oxygen is found to be more electronegative, right? Now since it is more electronegative, what will happen? You won't find maximum electron density on the carbon, right? So that means more electronegativity causes what? Less electron density, where in the less electron density in its proximal vicinity. That means, I mean to say, both the carbon as well as the pi cloud, fine. Proximal vicinity, fine. Chalo. Now, so that means what we can say, the nitrogen is found to be superior with respect to reactivity, fine, because it can readily give its lone pair to the pi cloud, right? So if the availability of the pi cloud is found to be more, what will happen? It can readily respond to an electrophile, right? But since oxygen is found to be more electronegative, that is why always the lone pair is trying to be with the oxygen, fine. It cannot be given, it cannot be readily given to the neighbors, right? So that is why it will not respond readily towards an electrophile, towards an electrophilic aromatic substitution, fine. Chalo. So we had done with nitrogen containing heterocycle, we had done with oxygen containing heterocycle. What is left in the process? That is sulfur. Sulfur is found to be less electronegative than these two, right? Nitrogen as well as oxygen, fine. And moreover, sulfur is having mesomeric effect, but that is found to be less. Why? Because, see, if I just write the structure, so here one interesting fact is coming, right? What is the interesting fact? See, sulfur is having a pair of lone pairs, fine, pair of lone pairs. Now, why the mesomeric effect is found to be less here? The mesomeric effect is found to be less over here, fine. It's less. Why it is less? Because there is an improper overlapping of what? P orbitals, fine. Improper overlapping of P orbitals. Why there is an improper overlapping of P orbitals? Because if I just see the overlapping here, fine. So this is the carbon, and carbon here is having it is in sp2 orbital, fine. What about sulfur? It is having two lone pairs and two bond pairs, fine. So that means here it is sp3, fine. Do you think that sp3 and sp2 can overlap in a best possible manner? It's not like that. That means here the overlapping between the sulfur as well as carbon is found to be poor. So that is why the mesomeric effect is found to be less. Sulfur, it is having two lone pairs and two bond pairs, right? So that means which corresponds to sp3. Carbon is here 1, 2. This one is what? Okay, hydrogen is there, fine. So it is having 1, 2, 3. 3 bond pairs, no lone pairs. So that means sp2. So that means if I want to, and what about this bond, right? This bond is taking place. This bond is formed because of the overlapping, fine. But here the overlapping is found to be ineffective, or rather what we can say, here the overlapping is found to be non-effective. So it is because of the non-effective overlapping of orbitals Okay, so what will happen? The mesomeric effect seems to be less. Why mesomeric effect seems to be less in case of sulfur containing heterocycle? Because here the overlapping is not found to be proper. It is because of the improper or non-effective overlapping of orbitals. So that is why sulfur containing heterocycle always suffers. Suffers from what? Suffers to provide what? Or suffers to produce what? Greater reactivity, right? So with all this information, are we able to present, or are we able to generate what the order of reactivity? Fine, yes, of course. Now, so it is the nitrogen containing heterocycle that should be kept at first, because this is found to be highly reactive one, because by virtue of this heteroatoms plus M effect, the mesomeric effect seems to be higher in case of pyrrole, because nitrogen is found to be the one in which plus M effect is found to be higher, or highest, what we can say, than the rest. Fine. Then comes what? Then comes here furan. Then comes here furan. Fine. Chalo, furan. And finally we have thiophene, right? So in case of thiophene, though you can find mesomeric effect, but that is not found to be more, right? So, and why it is not more, as explanation was already done, right? Or was already given. Fine. Mesomeric effect is found to be less. Why? Because of the poor overlapping between the sulfur as well as carbon. The orbital overlapping is found to be ineffective. So that is why sulfur has to be kept at last. So as far as reactivity is concerned, it is the pyrrole that is found to be highly reactive than furan. Furan is found to be more reactive than thiophene. So here the order is found to be pyrrole, then furan, and then your thiophene. Now let us just have a quick brush up, right? What we studied here. So if we are being asked to write the relative reactivity, relative aromaticity as well as reactivity of pyrrole, furan and thiophene, right? So coming to aromaticity, so here the rule of thumb is what? You must know that aromaticity and electronegativity, how we can correlate them. Aromaticity is found to be inversely proportional to electronegativity. Fine. So now you have to look back to the periodic, the positions of each atoms, right, in the periodic table. What we observe that here oxygen is found to be more electronegative than sulfur and than nitrogen. Fine. Nitrogen is found to be more electronegative than sulfur. So that means sulfur is found to be least electronegative, and we all know the relationship. So as sulfur, that means the sulfur containing heterocycle should be kept at first. Why? Because here the electronegativity seems to be least, and that is why the aromatic character seems to be higher. Fine. Aromatic character seems to be very prominent, very distinct, what we can say, very intense. Fine. Then comes pyrrole, because if I just compare the electronegativity of pyrrole as well as furan, it is the nitrogen that is found to be less electronegative than furan. Nitrogen is found to be less electronegative than furan. That is why it has to be kept at middle. And finally, we are done with we have to keep what? The furan. So furan is found to be least aromatic than pyrrole, and pyrrole is found to be less aromatic than thiophene. So this is all about your aromaticity as well as the relative aromaticity of this three heterocycle. Now coming to the reactivity, in case of reactivity, you are not supposed to abide by, or rather stick to this particular relationship. Rather, you have to explain this particular reactivity with respect to mesomeric effect. Fine. So mesomeric effect is found to be highest in case of nitrogen. Fine. So that is why nitrogen containing heterocycle should get the privilege. Fine. And that is why we have to keep pyrrole at first, right? This is found to be more reactive or highly reactive, because here the lone pair can be readily given to the pi cloud, right? And as it is readily available, as it is more available within the pi cloud, so that is why for electrophilic aromatic substitution, pyrrole can respond in a quickest way. Fine. Chalo. Now then comes at the middle, we have kept what? The oxygen containing heterocycle as furan, and sulfur. Why it has been kept at last? Because in case of sulfur containing heterocycle, though mesomeric effect is observed, but that is found to be less. Why? Because of the non-effective or ineffective overlapping of orbitals. Fine. So here sulfur is having sp3, carbon is having sp2, so there is an ineffective overlapping, and that is why mesomeric effect seems to be least in case of sulfur, and that is why we have kept sulfur at last. So as far as reactivity is concerned, it is the pyrrole that is found to be highly reactive than furan. Furan is found to be more reactive than thiophene. So with that, we are done with what? The relative aromaticity and reactivity of pyrrole, furan and thiophene. So hope you have understood the pact and pile, okay, and the illustrative explanation of this particular topic, right? So if you want me to grow, rather, so that means if you want me to grow, please put your valuable comments, right, where exactly you feel stuck, or rather you are not feeling comfortable with this kind of videos, right? Let me just know, so that at least I can rectify that one, right? So anyway, thank you, see you in my next video.